Now we're going to look at some more examples of solving quadratic equations. We have 4 methods that we have looked at: factoring, completing the square, using the quadratic formula, and using the square root property. Now we have a quadratic here that doesn't have a constant term. So if we run through our possibilities, we realize that we can factor. It's not going to factor out into 2 linear binomials, but we are going to be able to factor out a common factor of x. Both those terms have a factor of x. We bring that out in front, and then we divide each of the terms by that common factor to see what's left. So if we divide 5x squared by x, we're left with 5x. If we divide 3x by x, we're left with 3. So just like when we have 2 linear binomials multiplied together to equal 0, we set those factors equal to 0 and solve, we can do that here. We just, in this case, have a monomial that we're going to set equal to 0, and then the linear factor. Well, setting x equal to 0 gives us a solution, and solving the other linear equation gives us the other solution. So yeah, negative 3/5 for our second solution. Okay, here's our next example. Let's take 5x squared minus 7x minus 6 equals 0. So we think about the options we could use. We could factor, we could use quadratic formula, we could use completing the square. Let's try factoring. So since we have that leading coefficient that's not equal to 1, we are going to use the grouping method. So to do that, we multiply the leading coefficient 5 times the constant term, which is a negative 6. That gives us negative 30. Now we want 2 numbers that are going to multiply to negative 30. They may or may not be those 2 numbers that we multiplied together to get negative 30. Because we want the 2 numbers that are going to add to the coefficient on that x term, which is negative 7. So if we run through those possibilities, we have 5 and 6, which isn't going to work. 2 and 15, that won't work. Our other option is negative 10 and 3. Okay, those multiply to negative 30 and they add to negative 7. So we replace the negative 7 in our original quadratic formula with negative 10x plus 3x. Okay, because if we combine those, we get back to that negative 7x. All right, now is when the grouping part comes in. We group the first 2 terms together and the second 2 terms together. And now is when we factor. We factor the groups separately. If we look at the first group, 5x squared minus 10x, there is a factor of 5x. And what we're left with is x minus 2 inside the parentheses. Now if we look at the second grouping, there is a factor of 3. We bring that out in front, and in parentheses we're left with x minus 2. Okay, we choose the numbers such that this is going to happen. Actually, let's rewrite that so we get x minus 2. Okay, so we have that x minus 2 in both of those groups. That can come out in front. And what we're left with from the first group is the 5x, and from the second group is the plus 3. So now we have 2 linear factors multiplied together to equal 0. We set both of those equal to 0 and solve for x. And that'll give us our solution. So we get x equals 2, x equals negative 3/5. Okay, let's look at another one. We're going to factor by grouping this one as well. So we start off by multiplying the leading coefficient 2 by the constant negative 3. Gives us a negative 6. Then we want to find the two numbers that multiply to a negative 6 and add to the coefficient on the x term, which that's going to be a negative 1. Okay. All right, this time it turns out to be the same two numbers that we multiplied to begin with to get negative 6. Rewrite the quadratic, replacing that minus x with plus 2x minus 3x. Everything else stays the same. Now we group the first two terms and the second two terms. And it doesn't matter, like the order of that plus 2x minus 3x, either way, this is going to work out. So you don't have to worry too much about what order you put those in. So that first group, we can factor out a 2x. And inside the parentheses, we're going to be left with an x and then a 1, plus 1. In the second group, we can factor out a negative 3, and we'll be left with a positive x and a plus 1. So in both groups, we end up with this factor of x plus 1, so we bring that out in front. And then write down what we have left. In the first group, we're left with 2x, and in the second group, we're left with a negative 3. We set those factors equal to 0 and solve for x. So we get x equals negative 1, x equals 3/2. This example, again, we can factor, we can complete the square, we can use quadratic formula. Let's use quadratic formula. So we're going to have x equals, first thing is a negative b. So since our b is negative 12, that'll be positive 12, plus or minus square root of b squared, so negative 12 squared gives us a 144. And then minus 4 times a, which is 4, times c, which is 11. It's all over 2 times a, so 2 times 4. So simplifying, we get 12 plus or minus, under the square root we're going to have negative 32. All right, we want to do some simplifying. So 12 plus or minus, well, we know that we're going to have an I if we bring that negative out, and 32 factors into 16 times 2, so we'll have a 2 left underneath the square root, and out in front, square root of 16 gives us a 4. And that's all over 8. We're not done simplifying. There is a factor of 4 in each of our terms. So 4 goes into 8 twice, 4 goes into 12 3 times, and 4 goes into 4 1 time. We can rewrite our solutions as 3 plus or minus I square root of 2 over 2. Okay, this example at first doesn't look like the form we're usually used to seeing a quadratic in. So we first need to get rid of those parentheses. So we'll distribute that x. So we get 12x squared plus 11x. And then if we move that negative 2 over by adding 2 to both sides, we get plus 2 equals 0. Okay, we could use quadratic formula. We could try to solve by factoring, by grouping. We could use either of those methods, or we could try to complete the square. I think we will go with factoring by grouping. So first thing we do is we multiply that leading coefficient by the constant. 12 times 2, we get 24. And then we want the numbers that are going to add or multiply to 24 and add to 11. Okay, so if we run through the possibilities, all right, there's 12 times 2, and that's not going to work. There's 6 times 4. That doesn't work for us. And there's also 8 times 3. Well, 8 times 3 will equal 24, and 8 plus 3 will equal 11. So we rewrite, replacing that 11x with plus 8x plus 3x. And then we got the plus 2. All right, again, it really doesn't matter what order we put those, we put those in. Okay, so now let's group first two terms together, the second two terms together. We look at those separately, factoring out a common factor from the first group. There's going to be a factor of 4 and a factor of x. So dividing 12x squared by 4x, we're left with 3x. Dividing 8x by 4x, we're left with 2. Now, let's look at the next one. So there isn't anything that we can factor out. So we're just left with plus 3x plus 2 as it is. We ended up with what we wanted. We have in both groups, we have a factor in parentheses of 3x plus 2. So we're going to bring that out in front. And then what do we have that's left over? Well, from that first group, we have a 4x. And what do we have from the second group? Well, there's actually an implied 1 there. So that in parentheses, we get 4x plus 1. And set each of those factors equal to 0. And solve. We'll get us our solutions. So we end up with x equals negative 2/3, x equals negative 1/4.